Okay, we want to magnetize a steel rod using a solenoid. So which diagram shows the most effective way of doing this? Okay, to magnetize a steel rod using the electrical method, we need a DC current. So C and D are out. Okay, and we have to place the steel rod inside the solenoid, not outside. So the answer should be A. Okay, we have 3 points here, X, Y, and Z at different points of a solenoid. So we are asked to compare the magnetic field strength. Point Y is directly in the middle of the solenoid, so it must be the strongest. And point X and point Z, they are at equal distance away from the solenoid. So the magnetic field strength should be the same. So the answer is B, equal at X and Z, but stronger at Y. Okay, in this question, we have a current that is flowing into a magnetic field. So if we were to use the Fleming's left-hand rule correctly, for option A, we should find that the force is coming out of the paper. So this is wrong. And for option B, the force should be going into the paper. This is wrong as well. And in option C, the force should be going to the left instead of the right. So this is wrong. And the only correct answer, it will be option D. Okay, we have a bar magnet that is being pushed steadily into a long solenoid connected to a sensitive meter. So when the bar magnet approaches the solenoid, the solenoid will experience a rate of change of magnetic line of force linking the circuit. Hence an EMF and current will be induced, and we should see a deflection on the sensitive meter. So how will the magnitude of the deflection be affected? It will only be affected by the rate of change of magnetic line of force experienced by the solenoid. And the only answer here, right, it will be how fast the magnet is pushed into the coil. The faster the magnet is being pushed in, the higher rate of change of magnetic line of force linking the circuit experienced by the solenoid. And option B, C, and D will only change the direction of the deflection and not the magnitude. So the answer should be A. Okay, we have a transformer here, and we are given the primary voltage, the secondary voltage, as well as the resistance at the secondary coil. So we can find out what is the current at the secondary coil, which is equal to V over R. Is 12 divided by 8, 1.5 ampere. Okay, then we can use the formula, which is power at the primary coil is equal to power at the secondary coil. So voltage of the primary coil times current of the primary coil is equal to voltage of the secondary coil multiplied by the current of the secondary coil. So we have 240 multiplied by current of the primary coil is equal to 12 times 1.5. So current at the primary coil will be equal to 12 times 1.5 divided by 240. This will give us 0.075 ampere. So the answer is A.